So next we have Hanyu Young and introduction to the Leopard board. Hanyu, are you online?
Hi, I'm Hanyu. I guess just waiting on the line to clear since I just unmuted the phone. I'm basically a consultant. I do all sorts of stuff there, and I've been doing a lot of work with the BeagleBoard, and I noticed that there's something called a Leopard board, and when Jason sent the mail to the Leopard list asking for someone to do a demo, I figure this is a good way to tell the Beagle folks about the Leopard board. So what is the Leopard board? Next slide, please. Okay, the Leopard board is basically a very simple board. It's very similar to the BeagleBoard. It's based around the DM355 there. It's functionally it's a little bit different. It's mainly targeted for kind of more immediate applications there. This board, unlike the BeagleBoard, actually has a camera on there, a raw CCD interface, so you don't have to go through USB or any of the other funny interfaces to get to a camera. Since it exposes the raw CCD interface, you could actually wire up your own camera. The board itself comes with a little module. You could get either VGA, which I think is the default module that it comes with, or you could potentially buy a 3 megapixel or a 5 megapixel module to go in there. The whole board, just like the BeagleBoard, is also low power. It's designed to be community supported. It runs Linux. There is various flavors of Linux available for that, and I'll get to that later. You could directly buy that from LeopardBoard.org. This is a little bit different. It doesn't go through DigiKey. Next slide, please. The Leopard board itself, like I said, it comes with the 640 by 480 sensor as a default. Another feature of that board is that it has composite output there, which means you should be able to directly plug it into your TV, and hopefully it will be less painful than doing it on the BeagleBoard there. The processor on the Leopard board uses a different frame buffer driver, so it should have less issues. It does not require the DSS2 stuff that you found in the BeagleBoard, the OMAP processor. There is no HDMI or DVI output on the Leopard board, unlike the BeagleBoard. This board also, like the BeagleBoard, has an audio interface. It also has an SD slot there. One nice thing about this board is that it has a built-in Ethernet interface, which is something that is lacking on the BeagleBoard. You could certainly add that there. But the nice thing about the onboard Ethernet interface is that you could directly use U-boot to boot off the network, which is something that you currently can't do with the BeagleBoard. This alt header, unlike the BeagleBoard itself, it uses a .050 pitch header, which means you got to work with a little bit finer things there to connect to it. And other features of this board is that it has the SD card slot there, so you could also boot off the SD card. You don't actually have to play with the flash, but this is a little bit less important since you could actually net boot on this particular board there. This thing is 5-volt powered. It takes actually the same 5-volt connector that you could use with the BeagleBoard. It has a serial console, same settings as your BeagleBoard setting. The biggest difference is that the cable here, unlike the BeagleBoard, which uses the AT Everex, I think it's a 10-pin header, this one uses a 3.5. I think it uses basically a small headphone-style jack thing there. So you need a little adapter cable to go from there to your PC. I think the boards actually come with that cable there. So that's a quick summary of the board itself. The next important thing is that the CPU. These boards, they're all based around a system on a chip, which means most of your important accessories, features will actually be determined by the CPU. Just like on the Beagle, the OMAP provides most of the features you're looking at it. The board itself is really just something that breaks it out. It provides that glue logic to let you talk to the outside world. This the CPU used on the Beagle on the Leopard board is the DM355. It's a member of the DaVinci family. It's designed mainly for media processing there. It has an ARM core on there. This is an ARM 926 EJS, which is an ARM V5 instruction set architecture. This is in contrast to the BeagleBoard, which has a Cortex A8 core in there, which uses the ARM V7 instruction set architecture. On board there, this to do the video processing functions there, it has a media accelerator. It could directly or JPEG. In fact, it could, according to the TI site for this particular chip, It could handle up to the high definition 720p resolution. The JPEG codec could actually handle up to 50 million pixels per second. All this is accessible through interface very similar to DSP Link and OMAP. So in theory, if you code your things to the right level with DSP Link on the Beagle, your code could mostly work on this board there with minimal changes. So which is another nice feature to favor DSP Link over DSP Bridge. This particular chip also includes an onboard LCD controller, so you could interface with an LCD. Just like the Beagle board, there is no direct LCD available on this thing there. You would actually have to build something, or hopefully someone will build one and provide one there. This thing, this chip, it doesn't, this other feature doesn't matter too much for the Leopard board, but DAX to handle the composites out is actually internal to the chip there. So if you want to actually use this as a basis for a project there, and then later on spin your own board, that's one less component you have to deal with there. Another important feature is that this board, unlike the OMAP boards, they actually have only one USB controller. This is similar to the OTG block on the OMAP there. It's different in that it has an internal PHY, which means that some of the problems you have with external things, like, for example, the TPS part on the Beagle board, which I think is causing some software issues earlier, that doesn't quite appear, but then there's a different set of problems there. Most of the Mentor USB code will actually apply to both boards there, so fix this to one will actually apply to both boards there. I think that's a summary in a nutshell of the DM355. Supporting this board there in Linux there. This is not as mature as compared to the OMAP support there. There is obviously the community tree that's maintained by Kevin Hillman. If you look, oh sorry, I think I'm jumping ahead myself.
I'll move to the next slide.
Oh, okay. I just remember I forgot to ask you to change slides. I'm going off the PDF file, so that's why I'm losing sync with you. Okay, the resources. There's the DaVinci tree, which is the community tree for the DaVinci support. This includes the 355. It also supports all the other members of the DaVinci chips, the DaVinci family. There's, I think, the higher end ones like the DM6446 there, but this Leopard uses the 355. There is the Leopard SDK available from RidgeRun. You could download it at the URL on the slide there. The nice thing about this particular SDK is that it actually supports the camera, unlike most of the other ones. The other ones are generic 355 dev kits there, which means to support the processor, but if you want to talk to the camera, you need to make sure you have the right code to interface with the CCD sensor. This is probably important if you want to be able to use this thing out of the box there. There is the DaVinci 355 LSP from Monte Vista. This is downloadable on the TI site. I think it's called the DaVinci Development Kit there. I originally required a password login to download, but I think there's been recent changes to not require that. But the last I checked a few days ago, that link was broken, so I don't know what's the current status of that. As alluded to earlier, there is the website there, www.leopardboard.org, that has links to the design information, just like the Beagle board. There is the Gerbers available, schematics available. You could actually, I think, get to the data sheets through links from there. One thing that is not available on there due to various complicated reasons is the data sheets for the actual imaging sensors. That's an unfortunate side effect there that I don't know what exactly is going on there, but the explanation on the mailing list is that there's NDA issues there that needs to be solved in order for that to be available. So moving on. Hopefully I'm not going too fast with people since I'm trying to squeeze this in well under 15 minutes and still allow for time to ask questions. Things you could do with the Beagle board, with the Leopard board there. I've been doing a lot of stuff with the Beagle board. Is to actually build your own open source camera. Since there's a sensor available, which is support through Linux there. There's a video encoder, which also has Linux support there. You have all the components there to build a open source video or just a static regular picture camera there. This is something that you could actually modify, have your own features there. You could interface a tiny LCD and just make your own camera. Of course, does it make economic sense? No. On the other hand, this is something that you could actually have all the little bits and pieces to that you'll control. You could actually have your software. You could add other features in there that you can't do with the commercially available cameras there.